The problem that we're going to work on today is working on a double replacement reaction, your standard type of reaction. And these reactions, sometimes they give precipitate, sometimes they don't. But if a precipitate is produced, we're going to make a solid. If you see no precipitate, we're going to have an aqueous solution. And so to illustrate, let's take a look at this problem here. We have some lead nitrate, and it's an aqueous solution with sodium sulfide, another aqueous solution. And let's predict what we're going to get. So the first thing we want to do is to write a molecular equation. And the molecular equation is just typical. You're typically used to just writing the equation predicting your products. And so in this case here, we're going to have PbNO3 2 aqueous plus the Na2S aqueous. And when we do our double replacement, we're going to switch our positive ions, just taking the ions and not the subscripts. And so when we do this, we end up with Pb and S, and we end up with Na and NO3. Again, you're taking the ions, not the subscripts. So we're not going to be taking this, we're not going to be taking this. And the next thing that we need to do is to make sure that our formulas are correct. When I evaluate the charges of things, nitrate is -1, and there's 2 of them. And so since there's 2 of them, Pb has got to be +2 to balance that out. When I look at the formula of sodium sulfide, sulfur is -2 and sodium is +1. There's 2 of them, each with a +1 charge. So when I look at the formulas of product, I have sulfur being 2- and lead being 2+, so that means that works out great. And nitrate NO3 is 1-, sodium is 1+, so that works out great as well. Now I need to balance my chemical equation. I have 2 sodiums, I have 2 nitrates, so that indicates that I'm going to need 2 sodium nitrates on the product side, and 1 PbS is adequate on the left. And now it's time to predict my products in terms of aqueous or solids. And so when I look at the solubility of sodium nitrate, I find that nitrates of sodium are soluble, so I'm going to put aqueous on that. But sulfides of lead are insoluble. And so this right here is our molecular equation. If I wanted to write an ionic equation, that's going to show everything that exists as ions. And remember, if you have an aqueous solution, that means that when it's in water, it dissolves 100%. So the lead nitrate is going to exist as Pb2+ aqueous, and the nitrate is going to exist as NO3 1- aqueous. And there's 2 of them. With the sodium sulfide is going to exist as Na1+ aqueous, and the formula says there's 2 of them. And the sulfur exists as sulfur 2- aqueous. Now, on the product side, I'm going to write the product right down here since I'm running out of space. PbS exists as a solid, not as ion, so we write it as a whole molecule together, not breaking it up. But the sodium nitrate exists as ions, sodium 1+, and there's 2 of them according to the formula, and also 2 nitrate, NO3 1- aqueous. And this is our net ionic equation, with all things that are ion written as ion, all things that are solids written as solids. Now notice that in this equation that you have some ions that exist on both sides of the equation. And we call those ions that exist on both sides of the equation spectator ions. So what are the spectator ions? In other words, ions that exist on both sides of the equation. And you'll notice, I will underline, that nitrate, NO3 1-, exists on both sides, and so does sodium 1+. So since they exist on both sides, the NO3 1 minus and the Na 1 plus are both spectator ions. Now the last thing that I want to do is I want to write what's called a net ionic equation. And the net ionic equation shows all of the ions that directly make the product. The ions on the left, the product that's a solid on the right. And so in this particular situation, what's my product that I make that's a solid? Well, the solid product is PBS. Now what are the ions that make PBS? Well, on the left side you see that I have Pb with a charge of 2 plus. Remember, it's a net ionic equation, so you better write ions here. Aqueous. And then you have sulfur, 2 minus, and that's also aqueous. All other ions are not written because they're spectators. And so these ions are not written, and we are left with what we want, our net ionic equation.